Welcome to tutorial 3.7 part 2. This is on limiting reactants just like part 1, and the only difference here is that we're not going to have any pictures to look at. Instead, we're going to rely on the table for us to figure out what's going on. So we're going to have, I think, 6 examples, and here's the first one. Imagine that we had 4 moles of hydrogen and we try to burn them with 5 moles of oxygen. The question is exactly how many moles of water can we make? So just like last time, we're just going to go ahead and assume that we can react all of the first reactant. So let's try that and see if it works out. So if I drop the 4 down, I say, okay, let's try to react all 4 moles of hydrogen. How many moles of oxygen do I need? I need half that many. So it follows a 2-to-1 ratio. So for every 4, we need 2. And then we'll make 4 moles of water. And if we look here, compare the 2 with the 5, do we have 2 moles of oxygen? Yes, we do. We have 5. So we can react both of these. And then we'll just finish up the bookkeeping. If we had 4 and we used up 4, there's nothing left when the reaction is done. Of the 5 that we had present, 2 reacted, so 3 are still left over. And there was no water to begin with, so we made 4 moles of water. So we end up with 4 moles of water. And that's it. That's the first example. Let's try this next one again. Mechanically, just go through the exactly same process. We have 4 moles of hydrogen and 1.5 of oxygen. And again, this time, we go ahead and drop the 4 down and say, all right, let's try to use up all 4 moles. And following the ratio, we see for every 4, we need 2 oxygens to make the 4 water, but we can't do it. So that's why they're crossed out. Why can't we do it? Because we don't have 2 moles of oxygen. We only have 1.5 moles. So since we cannot react the 4 moles of hydrogen, that means we can react the 1.5 of oxygen. So we backtrack and say, okay, we jumped ahead of ourselves here. We can't actually do this. Therefore, we can do the following. We can react all 1.5 moles of oxygen. Again, let's follow the 2-to-1 to 2 ratio. Double 1.5, that's 3. And the 1-to-1 ratio between hydrogen and oxygen tells us that we can make 3 waters. What do we have left over when we're all done? We had 4 hydrogens to begin with. We reacted 3 of the 4, so there's still 1 left over in our reacting vessel. All of the oxygen was used up, so there's no left over. We didn't have any water to start with, so since we made 3, we also end up with 3. All right, that's the second example. Hopefully that's making sense to you. Let's do another one, this time with a different reaction, the making of ammonia. Following the same procedure, we're going to start off by saying, okay, let's assume that we can use all 6 of the first reactant. If we can use them, what's the ratio? For every 3, we need 1/3 as many. 6 divided by 3 is 2. And we would make how much ammonia? Double the 2 is 4. And again, we look, do we have 2 moles of nitrogen? Yeah, yes, we do. We actually have 6. So we can react all 6 moles of hydrogen. Finishing up the bookkeeping, we had 6. We reacted 6. Nothing's left over. Of the 6 nitrogens that we started with, only 2 actually reacted, so 4 are left over. We did not have any ammonia, so we made 4, and therefore 4 will be left over when we're all done. This part down here, it looks a little artificial. That's just because I'm trying to use this box, this kind of table method to keep track of things. All right, let's do another one. Exactly the same thing. This time we have lots of hydrogen, 18 moles of hydrogen and 2 of nitrogen. Let's try to react all the hydrogen. And again, following the ratio, 18 divided by 3, we need 1/3 as many nitrogens as hydrogens, which would be 6. It doesn't work out. Sure, if we had 6, we could make 12 ammonias, but we don't have it. We only have 4. So we're dropping down that first reactant, the hydrogen, didn't turn out to work. So therefore we said, we'll just backtrack, say, okay, if we can't react all this hydrogen, we can react all of the nitrogen. So we'll go and drop the 4 down instead of the 6. And that works out. Say, okay, well, I'm going to react all 4 nitrogens. I need 3 times as many hydrogens. 3 times 4 is 12. And the ratio between nitrogen and ammonia is 2-to-1. So I need double of 4, which is 8. What's left over when I'm done? Well, I had 18. I used 12 of them. I had 6 left over. I don't have any nitrogen left over. And since I had no ammonia to start with and I made 8, I also have 8. Alrighty, let's keep going. Let's go to another example, this time with a little harder reaction, the burning of butane. Same kind of thing. I have 6 butanes and 50 oxygens, and what's going to happen? Well, let's try to drop down the 6 and see if it works out. Since the ratio is 2 to 13, I say, okay, 6 divided by 2 times 13 is 39 moles of oxygen are needed to react the 6. Do I have the 39? Yeah, I look up here. Yeah, I have got 50. I'm all set. I can react all of this material. And then following the 2 to 8 ratio, I multiply 6 by 4 to get 24. The 2 to 10 ratio between butane and water is a 5 to 1 ratio, so 6 times 5 is 30. So I end up with 24 moles of carbon dioxide, 30 of water, and of the 50, I only reacted 39 of the oxygens, so I still have 11 left over, and I don't have any butane. I think one more example, if I'm keeping track properly, or yeah, this is the last one. So let's look at this one. I have 12 of butane and 13 of oxygen. Same exact procedure. Drop down the 12, see if it works out. I say, okay, 12 divided by 2 is 6. 6 times 13 is 78. I say, oops, that doesn't work out. I need 78 oxygen, moles of oxygen, to react these 12 butanes. I only have 65, so we got to cross this out. Now that didn't work, I can't use the 78, and therefore I can't make the numbers that I wrote down over here. Yeah, they follow the ratio. This 4 times 12 is 48, and 5 times 12 is 60, but I can't make it because I'm going to run out of oxygen before I do. Therefore, I can drop down the oxygen. I drop down the 65. Dividing by 13 times 2 gives us 10. That I have 12, and so therefore certainly I can react 10 moles of the butane. And following the ratio of 2 to 8, which is 4 times 10 is 40, and 5 times 10 is 50, tells me how much carbon dioxide and water I can make. And at the end, I'm going to have 2 moles of butane left over. I think that's it. That's the examples. So hopefully that made sense to you. I went through it pretty fast, and I think if you go back and look over the video, go nice and slow, stop it if you have to kind of look at those ratios, make sure they make sense to you. I think you'll see the whole thing makes sense. Follow a nice kind of set procedure, and you won't get confused along the way. All right, that's it. We'll see you in class. Thanks.